In this video, we're gonna learn what we call the synthetic division. So the synthetic division only use the coefficients. So only use the coefficients. So we are gonna write the variable term and use to find the quotient. So use to find the quotient. Use to find the quotient. Use to find the quotient when divided by x minus a factor of the form x minus a. So we only use the coefficients and use to find the quotient when divided by a factor of the form x minus a. So let's look at several examples. And here a is a 0. I mean, it may or may not be a 0 because we don't know whether the x minus a completely divide the polynomial. So let's look at some examples. So example 1. So the question is find the quotient when let's say 2x cubed plus 3x squared minus 2x minus 3 divided by x plus 1. So if you get something like that, you first want to rewrite this in this form. So what we can do, we can write this one as x minus 1 because we are looking for this particular value. It has to be of the form x minus something. So that means if you have x plus 1, you can put 2 minus sign and write like that. So now what we're gonna do, we're gonna from the tabula like this, we write the quotients, and you also want to make sure that you have all the degrees, because you can see start with 3 and then 2 1 0. So we have everything. So what we can do, we can write the only the coefficient. So we can write 2 and the next coefficient is 3, next coefficient is -2, the next one is -3, and then what we can do, we're gonna put the 0 here, that means -1, and then we can like kind of put a notation like that. So see, it's a -1, it's not 1 -1 because you have to write in the negative form. So when you write in the negative form, your number is -1. Now what we're gonna do, it's a very simple argument. We draw a line, we're gonna copy this number 2 down. So first number you copy, and then what we're gonna do, we're gonna multiply this number with that number. So that's the multiplication step, and then you're gonna put it there. So you're gonna add that number here. So that's what we do every time. So so when you multiply, you get -2. So you're gonna put -2 there and add the 2. When you add the 2, you get 1. Now what we can do, we can do the same thing. So we can start the new number. You're gonna multiply this number. First multiply and then add. So when you multiply and then you put it there. When you multiply, you get -1. So you put -1 here. And then add the 2. So you get -3. And do the same thing. So we can start with that number. And then you're going to multiply this. And then put that number here. So when you multiply -1 with -3, you get 3. And you put it there. And you add, you get 0. You get 0 means something. You get 0 means it completely divide by that factor. So if you get a 0 means it's completely divide. So that means, in other words, this means that when you divide 2x3 plus 2x squared, not 2x squared, 3x squared, 3x squared minus 2x minus 3 by x plus 1, you're going to get the quotient. So how to write the quotient? You can see that there are three terms, so that means it is a quadratic. So we can write this in other words, because there are three terms, that means it should be 2x squared plus x, because these are the coefficients, minus 3. Because there are three terms, so it is a quadratic. So that means that's the answer. So that means we can write this one as, so that means it should be 2x squared plus x minus 3. So that's the answer. You can write, this is one way to write it, or you can cross multiply and you can write it like this also. We can say 2x cubed plus 3x squared minus 2x minus 3 equal, you can say write the quotient first. So 2x squared plus x minus 3, that's the quotient, and then you multiply by the a divisor. So that's the divisor, we write it like that, and there are no remainder. So yeah, so it's very simple, and this is what we call the synthetic division method. So it's very fast. So what you do again, you first you have to write your divider in the minus form. So if it is a plus sign, we put minus minus, and then we pick -1 as the number, so we put the -1 here and write the coefficients, and then what we do, we multiply, add, and then until you get a number there. If you get a 0, that means there's no remainder, that means it's completely divided. Okay, it's completely divided. So let's do a few more examples just to understand the argument. Good. So the next example, so let's do this example. So let's say we have divide 3x cubed minus 4x squared plus 5x minus 7 by x minus 2. When you look at this problem, you can see that it's already in the right form, x minus a form, so things are easy. So we can write the coefficient first, so it is 3, -4, 5, -7. We are divided by 2, so we put that notation. The first thing we do is we're going to copy 3 down. The first step, we're going to multiply. We're going to multiply and add. So when you multiply 2 and 3, you get 6. When you add, you get 2. Again, you multiply and add. So when you multiply, you get 4. So add, you get 9. And again, you multiply. So you're going to get 2 times 9 is 18. When you add, you get 11. So so that's it. So that means if you divide the polynomial by x minus 2, you get a quotient of 3x squared plus 2x plus 9 plus a remainder of 11. So you can write this in this form. So you can say that if you divide, so you have 3x squared plus 4x squared, 3x cubed minus 4x squared plus 5x minus 7 equal the quotient first, 3x squared plus 2x plus 9, because those are the coefficients. You divide this one by x minus 2 and you get a 11 as a remainder. So you can see that's the remainder, and that's the quotient. Okay, so quotient. So this is one way, and you can also write in the other form. So let's do another problem. So let's say this one. Again, divide 3x cubed plus 5x minus 7 by x plus 4. In this problem, there are two problems. One problem is x squared term is missing. So you notice that x squared term is missing. So that means you have to add a 0 to the tabula. And also x plus 4. So x plus 4, you have to write this one is x minus minus 4 form. Okay, so let's talk about those. Just take those two into account. So that means when you write the coefficient, you want to make sure that you put a 0 for x squared term. Otherwise everything is wrong. So we have 3, 0 x squared, 5 and negative 7. And then here the number is negative 4. Good. Now what we're going to do? We're going to copy the first number, multiply. So we're going to multiply. So that means when you multiply negative 4 times 3, you get negative 12. Add, you get negative 12. Multiply, you get negative 4, negative 12, that means 48. Add, you get 53. When you multiply, how much you get? You're going to get negative 4 times 53 means negative 212. And when you add, you get negative 219. Good. So that means when you divide 3x cubed plus 5x minus 7 by x plus 4, you're going to get the quotient 3x squared minus 12x plus 53 plus the remainder is negative 219. So you can write as negative 219 over x plus 4. So we can write it like this because it's the same thing. When you divide, what will happen? You get the quotient and the remainder. So this is the quotient part. So this is the quotient, and this is only the remainder part, but we divide by the divisor and write it like that. So this is the remainder part. So these are two different ways to write the answer. This is one way to write it, this is the other way to write it. So there are two ways to write the answer. Now I'm going to show you one example, one application of this one. Let's say, so if you know a little bit about integration, I can show you one nice example here. So let's look at this problem. Let's say you try to integrate this expression. For example, 3x cubed plus 5x minus 7 over x plus 4 dx. So let's say you try to integrate that. Unfortunately, there are no quotient rule for integration. So there's no quotient rule for integration. So what you have to do is you have to use a division like that. But we know that when you divide those two, you're going to get two expressions. What are the two expressions? You get one expression. The quotient is 3x squared minus 12x plus 53. That's the quotient part. And also you have a negative 219 over x plus 4 term. That's the remainder term. So what we can do, since this is exactly equal to those two, what we can do, we can integrate them separately. So instead of this, we can integrate these two. So that's what we can do. So we can integrate that and we can integrate this. See the benefit? Now we can simply do this. So just use the power rule. So that means it is 3x3 over 3 minus 12x squared over 2 plus 53x. We are not going to add the c yet. Minus. So this is simply the natural log. When you have x plus a term, it's just a natural log. That means it's 219 natural log x plus 4. Now you add the c. So if you simplify this a little bit, you can see this is just x cubed minus 6x squared plus 53x minus 219 natural log x plus 4 plus c. So you can see the benefit just knowing this simple division technique. So you can integrate a lot of nice expressions. Okay, that's just a side note. So if you don't know anything about that, you can just wait. You can learn that very quickly, like very soon. Now, let's look at another problem. So this is the next example. How we can, let's say you want to divide by a not just a degree 1 term, but degree 2 term. For example, like this. So you can just extend this technique for like a larger, like to consider many other cases. So divide, let's say 2x to the 5th power plus x to the 4th power minus 6x cubed plus 4x minus 1 by, let's say, x squared minus 1. So it's a degree 2 polynomial, but our technique only works, it looks like it only works for degree 1, like x minus 8 term. Not really. What we can do, if we get something like that, we can look at the factors of that. What are the factors of x squared minus 1? You can see there are two factors. One is, you can see x minus 1, and the other factor is, you can see x, other factor is x plus 1. So x minus 1 and x plus 1. So those are the two factors. So now what we're going to do, instead of dividing by x squared minus 1, we can divide 1 by 1. So we're going to start with the first one. So if you start with the first one, that means the number that you want to deal with is 1. So you're going to start with 1. And then next time you're going to start with, because you can write this one as x minus minus 1, then you can start with minus 1. So let's divide by 1 first. So that's the trick. So we're going to start with the coefficients. So the coefficients are 2. See whether we have all the coefficients. Yes, in this case we have all. So 2, 1, negative 6, 4, and minus 1. So we have, oh no, we don't have 0 here. So you have to include the 0 here. So we're missing 0. So let that 0, because we don't have x squared term. So it's a 0. And then, nope. So we have to add to the wrong place. So we have 2, 1, negative 6, and a 0, and then 4, and then minus 1. So those are the terms. Don't even skip at least one. I mean, then everything is wrong. So we will start with, so it doesn't matter which one, but we start with the easy one first. So let's start with the first one. So we're going to start with x minus 1. That means 1 is the number. So copy the first number down. Then multiply. So you can get 2, add, you get 3, we multiply 3, you add negative 3, multiply negative 3, add negative 3, multiply negative 3, you can see add, you get 1, when you multiply you get 1, when you add you get 0. Good, that means it divides, so it's a good sign. So completely divide, that's what it means. So completely divide. When you get a 0, that means no remainder. That means works well. Okay, now just do the same thing. The next one we can divide by x plus 1 factor. That means the number going here is negative 1. So same thing, we're going to copy it down. So we're going to copy down 2, multiply negative 2, add 1, multiply negative 1, add negative 4, and then multiply, you get 4, add 1, when you multiply negative 1, add 0. Good, that means again completely divide. That's a good sign. So that means that's the quotient. Okay, so that means we can write this one as, when you divide 2x to the 5th plus x 4th minus 6x cubed plus 4x minus 1, you get the quotient. There are 4 terms, that means a cube. So 2x cubed, you get a 0, that's okay, it's just a number. So you get plus x squared minus 4x plus 1 times the two factors, but you can combine them, you can write x squared minus 1. So that's the answer. So you can see we can even use a synthetic division for to divide even by larger factors when you can factor into linear factors. If you can go to linear factors, we can still use a synthetic division for that case as well. But normally we believe that you cannot do it, but no, you can. Okay, so let's do just one more example to consider another special case. So this is the next special case. That's the last example we do. How about this one? Let's say divide. So these are special cases actually. 3x cubed minus 4x squared plus 5x minus 7 by, let's say you want to divide this one by 2x minus 1. 2x minus 1. This doesn't look the right form. So what we're going to do, we're going to take 2 as a factor and write it x minus, you divide, you just take 2 as a common factor, that means you divide everything inside by 2. So that's what you get. You take 2 as a factor, you can write this one as x minus 1 half. So 1 half is the number that you want. So let's see how it's gonna work. So we do the same way as we did before. So we can start with 3, negative 4, 5 and 7, negative 7. We have all the numbers now. So your number that you're dealing with 1 half, that's the number you're dealing with. Same trick. Copy the number down. Multiply. When you multiply 3 by, so we can multiply by 1 half by 3, so you're going to get 3 halves. When you add, you're going to get negative 5 halves. You're going to multiply, so you're going to get negative 5 fourth. And then when you add 5 and negative 5 fourth, you're going to get 15 fourth. And then when you multiply, you're going to get 15 eighth. And when you add, how much you get? 8 times 7 is 56, so you get 49 over 8. Good. So that's what you get. Now this is what we're going to do. So let's write this. So that means if you divide 3x cubed 4x squared plus 5x minus 7 by x minus 1 half, you're going to get this. So you're going to get, there are 3 terms, that means it's 3x squared minus 5 half x plus 15 over 8 times x minus 1 half, because you divide by this factor. Now what we can do, we can do a really nice trick, because you want to get your factor back. So what we're going to do, we're going to multiply this side by 2, we're going to multiply that side by 2, because this is simply 1. So we're going to multiply the first factor by 1 half, the second factor by 2. When you do that, what do you get? This simply you divide everything by, yeah, actually this is 4, like put 8. You divide everything in the first one by 2, so that means you're going to get 3 halves x squared minus 5 fourth x plus 15 over 8. That's the first factor, and for the second factor you multiply by 2, that means 2x minus 1. That's exactly what we want. We want to know when you divide by that. Okay, I forgot the last term. We already had a remainder. Remainder is 49 over 8. That's still sitting there because we did not multiply that term, so that's no change. So you can see, you can simply use a synthetic division even to handle some cases that looks impossible. Okay, so that's how we use a synthetic division. Very easy. As the final example, we're going to do this one. So we're going to do divide x7 plus 1 by x plus 1. So if you get something like that, you can see that there are a lot of terms missing. So let's write them first. X plus 1, this is equals to x7 plus 0 x to the 6th, 0 x to the 5th, 0 x to the 4th, 0 x to the 3rd, 0 x squared, 0 x plus 1. So that means you can write your tabula like this. So 1. So we have 1, 2, 3, 4, 5, 6, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros and a 1. And then this is x plus 1. So with the minus sign, you can write this one as x minus minus 1. So that means the number is negative 1. So we're gonna copy the first number down, multiply, so you get negative 1, add negative 1, multiply, so it's 1, add 1, multiply is negative 1, negative 1, when you multiply is 1, 1, multiply, negative 1, negative 1, and then multiply is 1, so it's 1, and when you multiply is negative 1, add 0. So that's perfectly fine. That means it's completely divide. The 0 means completely divide. So then we can write the factors as x7 plus 1 equal, if we divide by x plus 1, the quotient is, so you can see this is x, so x to the 7 should be x to the 6th, and then minus x to the 5th plus x to the 4th minus x cubed plus x squared minus x plus 1. So yeah, so even works for problems like that.